So Unit 19, angles, dovetails, and slots. So measurement of angles. Some objects do not have their straight lines drawn horizontal or vertically. The design of the part may be required, or some lines to be drawn on an angle. The amount by which these lines diverge or draw apart is indicated by angle dimension. The unit of the measure, such as angle, is the degree and is denoted by the symbol of the degree symbol. There are 360 degrees in a complete circle. On a drawing, 360 degrees may be written as 360 with the degree symbol. So, it shows you some different angular surfaces there. So angular dimensions, sizes of the angles are measured in degrees. Each degree is 1/360th of a circle. The degree may be further divided into smaller units called minutes. There are 60 minutes in each degree, and the minute may be further divided into smaller units called seconds. There are 60 seconds in each minute. For example, an angle measuring 10 degrees, 15 minutes, and 35 seconds would be a typical dimension specified degrees, minutes, and seconds. Angles may also be specified in degree or decimal parts of a degree. For example, a dimension of 30 degrees in 30 minutes can be shown as 30.5 degrees. Specifying angles in decimal parts of a degree is a preferred method. However, angular dimensions displayed in minutes and seconds are still found in many engineering drawings. Implied 90-degree angles. Surface features and center lines intersecting at right angles are not specified with angular dimensions of 90 degrees of the drawing. It is generally understood that lines of the surface shown to be at right angles will be 90 degrees unless otherwise specified. The standard tolerances for implied 90-degree angles is the same as the standard tolerances specified at 2 or 4 other angular features of a drawing. So angular surfaces or tolerances. Angular tolerances may be specified on the object in a standard tolerance block. As with other dimensions, standard tolerances may apply unless otherwise specified. So angular tolerances specified on the drawing. So you got 30 degrees, 59 degrees, plus or minus 2 degrees. So you got all these different ways of, so limits on angular dimension, plus or minus 1/2. Tolerances, so all different ways of putting it. So dovetails. A dovetail refers to a groove or a slot which sides are cut at an angle, making the interlocking joint between two pieces so that as to resist pulling apart in all directions except along the ways of the dovetail slide itself. The dovetail is commonly used in design of slides such as machine parts, as the cross slide of a lathe, the slide on the underside of the milling machine table, and other sliding parts. The two parts of the dovetail slide are shown in cross section in figure 19.3. So there's the 19.3. The edges of a dovetail are usually broken to remove the sharp corners. On large dovetails, the external and internal corners are often machined as shown in 19.4 at A or B. So A and B. So flats, fillets, radius. And dovetails are usually dimensioned as shown in figure 19.5. The dimension limit of the boundaries to which the machinist works. So A or B. So either the bottom or the top. Alright, measuring dovetails. Female dovetails are measured by placing 2 accurate rods known as of a known diameter against the sides and the bottom of the dovetail as shown in figure 19.6. Male dovetails may also be measured in a similar manner by placing 2 accurate rods of known diameter against the sides and bottom of the dovetail in figure 19.7. Acceptable limits for dimensions Q and R are calculated based on the angles of the surfaces and the size of the rods. So you're just checking for R and Q. T-slots. T-slots are frequently used for clamping the work securely. Drill press and milling machine tables are examples of T-slots that are used. Work to be machined or work holding devices are clamped using T-slots and T-nuts. Special cutters are used to machine T-slots. T-nuts slide along the T-slots and are typically used with bolts to secure parts into position for machining. The T-nuts have threaded holes so that the bolt of appropriate length can be connected. T-bolts can also be used where their heads sliding the T-slot, with the bolt exiting to reach clamps that are used to secure parts. As with dovetails, T-slots and T-nuts are symmetrical and are displayed with a symmetry line in figure 19.8. So symmetrical. And there's a sketch that you can draw, and then there would be the next unit that we will actually do. So this will be your next assignment, and there's your questions. Thank you.